Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by TechStrong and WhiteSource. My name is Cody J. Brown, host of TechStrong Learning. We have an exciting presentation ahead of us, but before we begin, I have just a few housekeeping notes. First, today's event is being recorded, so if you miss any or all of today's event, or you just like to share it with a friend, you will receive an email with a link to access the on-demand after today's webinar concludes. I'd like to direct your attention to the Q&A function. It's on the right side of your screen. This is where you can ask us questions for today's topic, and we will try to address those at the end of the seminar. You'll also find on the right side of your screen, there's a chat tab. We want you to engage with one another and with us through this chat tab. So just feel free to say hello, let us know where you're calling in from. And finally, at the end of today's webinar, we will have 4 $25 Amazon gift cards to give away. So stick around to see if you're one of our 4 lucky winners. But on to today's webinar and a timely topic. We are facing the Log4j vulnerability head on, the risk and the fix. And I'm joined today by Shiri Ivstan, Director of Product for WhiteSource, and Daniel Elkabes, Vulnerability Research Team Leader for WhiteSource. It's my pleasure to turn the floor over to Shiri to get us started. Thank you so much for being here with us today.
Thanks, Cody, for the intro, and thanks everyone for joining. So definitely a very interesting and exciting webinar for all of us today. So we are going to discuss the Log4j vulnerability, Log4Shell vulnerability. We are going to look at what is the risk really, how risky it is. We are going to start and understand how to understand whether you are vulnerable. And then lastly, we are going to understand how to fix it, and specifically how to deal with this vulnerability in a larger scale organizations. So let's take a quick look at the agenda for today. First of all, we are going to understand in a very basic form, what is really Log4j, what's all the noise about it, why is this vulnerability so critical. Then we are going to make sure that you guys have the tools to know whether or not you're vulnerable. If you are vulnerable, and hopefully not, we will give you the tools on what should you do, how should you handle it, what is the action item. And then, of course, we are going to look at processes and how easy it is to handle Log4j vulnerability and similar vulnerabilities in a larger enterprise. And just a spoiler alert, it's not a trivial task at all. And then, of course, we will conclude with your questions. So feel free to post your questions in the Q&A tab. So with me is Daniel today, one of our best security researchers at WhiteSource. And Daniel, the floor is yours.
Hi, everyone. I'd like to thank the organizers of this webinar and thank you for joining us today. Disclaimer. All the information I'm sharing is correct at this time. As we all already know, there is a lot of focus now on Log4j and its related vulnerabilities, and new information might be revealed in the near future. In my section, I will talk about why is this vulnerability critical, the technical details of the vulnerability, including what is JNDI and how it is being exploited, how the code eventually being executed and not just being logged. I will show a live demo of the exploit. Lastly, I will refer to all the related vulnerabilities. I'll start from the foundation. So before jumping to the vulnerability, what is Log4j? Apache Log4j is a Java-based logging utility. Apache Log4j 2 is an upgrade to the first version of Log4j that provides significant improvements and supplies many of the enhancements available in Logback while fixing some inherent problems in Logback's architecture. Now we can move to the vulnerability. So why is this vulnerability critical? Because of the extensive usage of Java and Log4j combined with how easy it is to exploit this vulnerability, we get one of the most pressing vulnerabilities on the internet since shell shock, and hard lead. From a hacker's view, exploiting this vulnerability is child's play. In a nutshell, for a successful attack, an attacker needs to create an artificial server, which contains his malicious Java code, then supplying only one malicious string to the vulnerable application, thus gaining a remote code execution on the backend server. A bit of background. In 2013, in one of the beta releases of version 2, the Log4j package added the JNDI lookup plugin. To understand how this feature addition creates a vulnerability, it's essential to understand what is JNDI. JNDI is short for Java Naming and Directory Interface. It has been existing in Java since the late 1990s. It is an API for directory service that provides numerous usages such as it is a mechanism to bind an object to a name, a directory lookup that allows general queries. It allows clients to determine whether directory entries have been modified, and it can act as an extension to support additional capabilities like RMI and LDAP. To simplify for our case, it acts as a utility, which allows a Java program to find data in the structure of Java objects, which perform through a directory. JNDI has a number of service provider interfaces, or in short, SPIs, that enable it to use a variety of directory services. SPIs exist for NIS, NDS, Corba, Java RMI, DNS, and LDAP. We will concentrate on LDAP and RMI. LDAP is a very popular directory service and is the primary focus of Log4Shell. But lately we are seeing more and more POCs in other forms, many of them associated to RMI, which is short for Remote Method Invocation. It is an API that allows an object to invoke a method on an object that exists in another address space, which could be on a remote machine. At this point, it is unclear whether other SPIs like DNS would also lead to remote code execution. And please note, there are many POCs related to Log4j which adding a lot of complexity. In the following section, I will focus on LDAP and RMI. And in the sections related to the additional CVs, I will explain more about their issues, which are a bit different. Let's examine this scenario. A Java program may use JNDI and LDAP to find and import a Java object. The LDAP server could be anywhere, meaning that if an attacker can control the LDAP URL, they can manipulate a Java program to load an object from their malicious server. The issue that lays in Log4j is that an attacker can do exactly that. By providing Log4j a URL via LDAP for the JNDI functionality, Log4j parses it and connecting to the LDAP server. For example, in the case we see on the slide, it will retrieve the malicious code from attackerserver.com. Why this happens? Log4j allowing a special syntax of prefix and name, where prefix is a lookup and name is the evaluated key. The JNDI lookup by default have a prefix for his key with Java comp env. But if the key incorporates a colon symbol, the Java comp env prefix won't be added to the key. This may make it possible to query any LDAP server URL for a Java object. On top of that, this lookup is not restricted to the configuration of Log4j. It also can be used when lines are logged. Now all an attacker needs to do is to find a place that is logged with Log4j, injecting into it the payload with a simple line of code, consequently gaining a remote code execution on the server that Log4j exists on. Places that attacker can control and usually logged by the server are, for example, HTTP headers like user agent, referrer, which is typically logged, as well as x forwarded for. These headers are just a few examples of numerous possibilities. The payload might pass to any kind of Java-based backend server that you can think of. Due to this, it is crucial to remediate all vulnerable versions of Log4j right away. We covered what is JNDI and how it is being exploited, and it should be fairly clear by now why this vulnerability is critical. But how is the code being executed from just a log action? While obtaining the code from the remote server with JNDI using LDAP or RMI, we are encountering two scenarios. On all the JDK versions before JDK 8 update 1.2.1, when retrieving an unknown class, which means class that is not present on the target class path, JDK attempts to load the compiled class implementation using URL class loader. This led to straightforward exploitation by serving an arbitrary compiled class, which the vulnerable application loads and then creates an instance. The second scenario is on JDK 8 update 1.2.1 or above, which introduced new mitigations aiming to make JNDI injections harder. Now successful exploitation depends on what does the target's class path contains, since the attacker needs to use gadgets now. The mitigation they implemented in the JDK is checking an internal configuration variable named trust URL codebase before using URL class loader. Let's proceed to our live demo, which shows these two cases. Starting with the first scenario, where we are using old JDK version. In the burp application, we are sending a GET request which contains the input with our first LDAP payload. Moving to the IntelliJ, here we have a vulnerable Log4j application, which receives this input. Let's walk through the breakpoints to understand what is happening. The first breakpoint is the logger, which receives the input containing our JNDI payload, in this case using LDAP. In the next breakpoint, we see the usage of Log4j JNDI implementation. As we can see in the top of the window of IntelliJ, it's an implementation of JNDI in Log4j. Next, it tries to find the object in the class path. Moving to the next breakpoint. But it doesn't find it. And we can see it in the next breakpoint. It returns null. I think I might have added another breakpoint here. Mistakenly here. Here it returned null. Sorry for that. Unfortunately, in this old JDK version, it doesn't care if it exists in the class path or not. And in the next breakpoint, we see the code base that refers to the malicious server. Finally, we reach to the URL class loader new instance creation. And if we step over this, the code executions occur. Okay, moving to our second scenario, where we are using newer JDK version. Again, in the burp application, we are sending a GET request which contains input with our RMI payload in this case. start, like in the previous scenario. The first breakpoint is the logger, which receives the input containing our JNDI payload. In this case, again, we are using RMI. In the next breakpoint, we see the usage of Log4j JNDI implementation. Next, it tries to find the object in the class path, like the last time, which in this scenario, we are using a gadget called bin factory, as we can see here. And we can see it too in our evil project, which is here. And returning to our Log4j vulnerable application. So this will create an expression which the EL processor in turn will parse. Finally, we can see it calling the eval of the EL processor, which in turn executes our code, which in this case is a calculator. That's the end of the POCs. Getting back to the presentation. Now, let's review the status of all the related CVs. Currently, there are 3 more related vulnerabilities for Log4j and 1 related vulnerability in alternative product, Logback. These other vulnerabilities are highly dependent on a unique non-default configuration, and some leads only to a denial of service. But that doesn't mean you should doubt on the importance of resolving them, as they are still maybe harmful in similar aspects. Let's try to understand a bit more about each of these CVs. We covered in depth on the previous slides about the main CV. In each slide, I will refer to the vulnerable versions, the fixed versions, and the recommended fixed versions. Again, this is correct at the moment. Things may change in the future. The second CV is associated to first version of Log4j, which is deprecated. Due to this, there isn't any fixed version, and it's recommended to upgrade to the latest version of Log4j 2. What is the issue of the second CV? There are 2 places where JNDI lookup are made. It's within the JMS appender. If you set either topic binding name or topic connection factory binding name to something that JNDI can handle, as seen in the examples in the slide, which is a very specific configuration, then JNDI will do exactly the same it does for the main CV. The third CV on our timeline is associated to the alternative product Logback. Version 1.2.7 and all versions prior to this vulnerable version, again, versions 1.2.7 and all previous are vulnerable. And the issue in this vulnerability is pretty similar to the second CV. Well, the vulnerability depends on a really specific configuration in this case too. In this case, it's the logback XML. There needs to be a configuration of JNDI that creates access to untrusted site or malicious site via an appender, as you can see in the non-default configuration section. CVE number 4 on our timeline exists due to incomplete fix of the main CV. It occurs via a new POC. Again, in this case, attacker needs many non-default configurations and resulting in a remote code execution. Version 2.15 and prior are vulnerable to this. It is currently assumed that remote code execution is working only on macOS environment. The payload that can bypass the network host restriction is occurring like this. The java.net URI getHost method returns the value before the hashtag as the real host, but the JNDI LDAP resolver will resolve the full hostname string attempting to connect to the malicious LDAP server.
One sec.
The fifth and final CV for today. After disabling the JNDI functionality altogether and removing the message lookup feature, 2.16 was thought to be unaffected by any further exploits that are using the lookup. However, although it prevented remote code execution and even local code execution, it did not address crafted inputs that could manipulate the context lookup functionality. In this case, leading to a stack overflow and crash. How does this exploit work? The str substitutor and str lookup classes in Log4j core are responsible for parsing lookups that are made within layout patterns. If an attacker can control the user variable, which is stored in the thread context map and the pattern layout with the context lookup, as we are seeing in the slide, the next sequence will occur. The substitutor finds the value of user within the context map and replaces user with it. The value of it is what we are seeing in the slide in the payload box. It then tried to evaluate the lookup pattern that is in the value of the user. This is possible because of the recursive functionality of lookup patterns. Because user1 does not exist in thread context, the substitutor goes forward to the default value as last resort. The default value is a string that in itself is a lookup pattern, as we can see in the non-default configuration section. Then, referencing back to the user variable, note that it's the same as the original lookup in the configuration layout pattern. This means that the substitutor will forever try to resolve the variables by calling its substitute method again and again until the stack buffer overflows. At this time, these are all the CVs related to the new Log4j vulnerability. Thank you.
So thank you, Daniel. Definitely a lot of details. And we all understand how critical this vulnerability is. And some of us also understand the technical details. I have to say that I understand some of them. And we went and gathered some interesting statistics to understand how popular is this library, really, how popular is this vulnerability. And what we did is we went to dozens of top Maven projects, and we actually found that almost half of them are impacted by the Log4j vulnerability. Another interesting statistic that we found is that only 22 actually remediated this vulnerability. Either they upgraded to a non-vulnerable version or they switched to a different package. So this means that there is still a lot to do around the Log4j vulnerability, especially if you're maintaining an open source project. Perfect. So the next thing is to understand what should you do and how to understand if you're vulnerable or not. So the first step would be to scan your code. You can either do it with a commercial tool or with an open source tools. There are many open source tools out there to scan your open source code. This basically means that you can check versus your existing inventory if that vulnerable library is there. and if you have a vulnerable component. The integration with the scanning tool can be done in the IDE, in the repository like GitHub, GitLab, etc., or in your pipeline as part of a build step in your CI/CD, like Jenkins or TeamCity. You can also scan as part of your production environment. So after you scanned with one of the software composition analysis tools, and hopefully you found that you are not vulnerable, but what if you did? The next step would be to inform, to make sure that your developers actually know that there's a vulnerable component that they need to act upon. So they know exactly all the details of that library, what is the non-vulnerable version, and what they actually need to do. And then they would need to act upon it. They would need to remediate the vulnerability. They can either upgrade to a non-vulnerable version, which is the solution in the Log4j vulnerability, and also the solution in most open source vulnerabilities. Another option would be to completely switch this package to another logging method or logging component. So let's look at it in terms of a larger organization or a larger enterprise. And by now, you probably understand that the steps that I described before may look a little basic, even trivial. But handling vulnerabilities like Log4j in large enterprises is definitely not something trivial. A major part would be to sync everyone and understand that a big challenge will be to actually identify which parts of your software or your product are actually vulnerable to the Log4j vulnerabilities. In addition to that, if you maintain multiple versions of your product, it may be that something that was shipped to customer a year ago is still vulnerable. So you would want to check that as well. What you eventually want to do is you want to minimize the lead time from the vulnerability discovery to your team actually becoming aware of the issue. You also want to maximize the ability to respond and identify which applications actually use the vulnerable component. And then the next step would be to streamline the ability to recover. So you want to quickly upgrade the affected versions or application, or put compensating controls in place. Like, for example, a web application firewall in the example of the Log4j vulnerability. This actually brings us to the topic of how we address this kind of risk for software that we did not develop ourselves, but we still own managing the risk, right? Open source projects are things that we rely on. Actually, 80 to 90% of the code that's currently being written in the world is open source. So we all rely on it. It's public, it's free, it's great, but there are definitely some parts that are more challenging, like facing a vulnerability similar to this one. And some of us actually scan our software on a day-to-day basis. But there is a second aspect to this story, which is mature management of open source components. So, what do I mean by mature management of open source components? So, let's assume that you are using an SCA tool. In addition to that, you also need to have a working DevOps and DevSecOps processes. So, what does it mean? DevOps is automating basically any part of your software pipeline and CI/CD. Adding the security in the middle actually means that you can integrate the security aspects of your code into the DevOps lifecycle. Things like scanning as part of the pipeline, failing builds based on detected vulnerabilities, and basically just making a security be part of the process and not just an afterthought. In addition to that, another very good tool would be to keep your open source versions up to date whenever possible. So that means using tools like, for example, White Source Renovate that will open a new pull request every time there is a new version to an open source component dependency that you use. Another thing would be to have clear prioritization process, to have a security champion in each team, and again, making security part of your day-to-day processes. So let's assume you are using an SCA tool. And once you actually got an alert from this tool that scanned your software, the next question is, how do you respond? The security analysts in your team would probably see the alert and they will see what kind of applications or what applications are impacted. That is a very important step, but it's not the last one. In addition to that, of course, your developers will also get an alert. So the developers who own those applications would get notifications automatically too. Sometimes it would be via Slack, Teams, or even a Jira ticket that's being opened automatically by the tool, an email, depending on which tool you use and how the alert is configured. Then the next step would be to rapidly roll out an update. This is where we must look at the remediation capabilities, whether automatic or manual, and the organization DevOps capability itself. So, why are DevOps capabilities important? If you are not able to deploy your software and build it automatically, it will take you a lot of time to actually handle each and every one of these vulnerabilities. So, let's say you have a great SCA tool and the security teams got their alerts and they inform the developers, and now the developers also know that there is an issue that they need to fix. The next question, specifically in larger enterprise, is who owns this process? And this is, by the way, the answer of a report, a survey that we did last year. You have the full link here. And the question that we asked was, who owns the day-to-day operational responsibility for application security in your organizations? And you can see that the responses here vary from DevOps, security teams, developers, to even team leaders in software development teams. And there is no one specific person who owns the security. And this survey, by the way, was done in enterprises. So the responsibility for the security of our application traditionally has been in the hands of the company security professionals. This is pretty trivial and basic and makes sense. But what happens now? So previously, developers would design and build the product, and the security experts would perform the reviews, flag issues for remediation. So everyone pretty much knew what their role was. But these days are basically over now, and now the lines of who actually owns the security are a lot more blurry. So what we see is a clear movement of the ownership of the day-to-day operational vulnerability research and application security, with, even in this survey, 71% of the respondents actually stating that the ownership lies in the software development side, whether it's by DevOps teams, development teams, or the developer themselves. So this is a pretty interesting thing. And specifically in events like Log4j, we cannot really have this split responsibility and let everyone manage it, because then things would just fall between the cracks, like we've seen in many organizations. And this is a very big issue. So, what should you do now, but also for the next Log4j similar vulnerability? So, some of the things here may look a little basic, but still they are super important. So the first one is to set clear expectations and have policies in place, and also set priorities for the company for each application or product. Even a VP R&D that is saying in the beginning of this event, in the beginning of the Log4j vulnerability, that this is the company's top priority to actually handle this vulnerability, is something that makes a lot of sense for a lot of people. Even if we postpone a later version, or some of the tasks would split from the existing sprint, that's okay. We need to handle the current vulnerability. This is very important. The next thing is to assign clear owners on who report upwards and downwards. This makes either the security person or one of the developer team leads for a product one owner. If there are multiple owners, everything becomes blurry. Also, we would really want to avoid multiple communication channels. So we've seen in these specific vulnerabilities, companies that went from different private Slack channels to group Slack channels to Jira to emails, and not everyone was on the same page in terms of the vulnerabilities. Then you would want to adjust to the changing reality. So, as Daniel showed us before, the things change in terms of days. New vulnerabilities are being added. We understand more data on the existing vulnerabilities, and it's definitely crucial to just adjust and make sure that you are updated with the latest vulnerabilities. So, to conclude this part, you definitely should have alignment within the organization in terms of who owns the security, specifically in these events. There may be good things in the cooperation between security and developers and making sure that you don't have one clear owner. But in events like this, you definitely need to assign one. These are the main takeaways, and now we would be very happy to take some of your questions.
Wonderful. So we've received quite a few questions during today's seminar, so let's go ahead and get started. First one to come in is pretty straightforward. Who found this exploit?
I'll answer this question.
So Daniel, I think this one is for you.
Yeah, I'll cover this. So I hope I pronounced his name correctly. If not, please forgive me. It's Chen Zhaojon from Alibaba Cloud Security Team, who found the Log4j vulnerability and responsibly disclosed it in private directly to the Log4j developers.
Awesome. And Shuri, how about I'll field this one to you. What kind of security training needs to be in place in large organizations?
So this one is pretty broad. There is definitely a need for security training, but security training is not just about, your open source components. So if we talk specifically about application security, what we found is that even if there is a very good security training program, a lot of times the developers are not even aware of it. So if you are a security person and you are deploying a new security plan or security training, the first thing that you need to understand is that developers may not be security experts, but they do understand insecurity more than the average person. So you would want to adjust your plan to how developers think. The next thing is you really need to make sure that the developers are aware that there is such a program and that they know what they need to do. The second thing is something that I also touched upon as part of the webinar, is having a security champion. This is someone in each and every team or each and every squad that is responsible for making sure they have alignment with the security team, and they're sort of the champion within the team. So if there is a security training, they're the ones who socialize it, make sure that everyone passed through it. This is very important. Now, with regards to what needs to be in the training, this is definitely specific to each and every organization, but definitely needs to have parts of, application security, static analysis, how to write secure code, but also how to use open source components safely. I hope that answers the question.
All right. So our next question is for Daniel, and how would a real-world attack look?
Well, for example, it can be some social media which has much information that is being logged, like errors or unique details they want to log, or even servers written in Java that do some periodically work on data like indexing, and then they log the malicious string which contains the exploit. And this can occur even months after the malicious string received, that the indexing of it and the Java code finding it, logging it, and eventually achieving a remote code execution on your backend server.
Excellent. Our next question, I believe this one is for Cherie as well. Cherie, but it is, what is the role of developers in handling such vulnerabilities, and do they need to be security experts?
So this is a good question because we keep hearing about, developers need to be more security aware. They are the ones who need to act upon these vulnerabilities and handle them. So I think the answer to this question varies on who you ask it. In my opinion and my view is that developers don't need to be security experts. We cannot expect it from them. They have more important things to do, like deliver great features and write really good code. But they need to be aware of the security aspects. So if there is a vulnerability that they are informed on, and assuming you have the right tools, you were informed on Log4j, from the moment that you know that there is a vulnerability, you need to do your best in order to remediate it. Some developers would be pretty hesitant to upgrade to a latest version. What happens if something breaks in my code? What happens if something wouldn't work after it? But it's really important to understand that in vulnerabilities like Log4j, security is the most important thing, and we cannot compromise on it. So even if it requires more testing, even if it requires other tools to make sure that it doesn't break anything, it's still very important. So to maybe conclude, developers don't need to be security experts. They need to be supplied with the policies and with the tools that will inform them and let them know how to fix the relevant vulnerabilities.
Outstanding. So Cherie, could you provide us with a couple tools to detect the Log4j issue?
So this is a very good question. So again, if you are already using an SCA tool like WhiteSource or a similar tool, you should definitely use that one. If you're using WhiteSource, by the way, you should already have, if you scanned your code, you would get a real-time alert like I described. So if you have a Jira integration, a new Jira ticket would be opened. If you don't have any integration in place, you would get an automated email. If you're not using an SCA tool, there are some great open source tools out there. If you're interested specifically in detecting the Log4j issue, WhiteSource actually released an open source tool, a CLI tool, to detect only this specific vulnerability. So you can definitely look it up and use that one. No sign-in is needed. Also, there are various open source tools that you can definitely go ahead and look and find to understand and detect the Log4j issue. These were just some examples from my experience.
All right, so what is the best way to know that my project or product is affected directly or indirectly?
So this is pretty similar to the previous question, right? If you scanned your code using whatever method, right? These kind of scanning tools would have sometimes different methods. Some of them rely on the digital signature to understand whether you're using a vulnerable component. Some of them would use log files or manifest files. So there are various tools there are various ways how these tools work. But eventually, in order to understand if you are vulnerable, if you have a vulnerable component, all you need to do is scan your code. These tools can scan locally, right? To understand if you can scan in your Jenkins server or even on your local machine if you have package managers deployed and installed there. But you can also scan in your repository. Like if you have a GitHub repository and you want to know if that one is vulnerable, you definitely have tools to detect that as well.
Perfect. And so I'll end with this final question, but is there any kind of site to keep us updated on vulnerable components or kind of updates on this Log4j issue?
Yes, definitely. So first of all, it's all over the web. I guess no one was able to miss this vulnerability. But if you want to get really good updates, again, my opinion is the white source blog posts. So Daniel, who is here, has written some of them with the great help of his team, security researchers team. And we keep on updating the existing blog posts, right? Even the one that we released a couple of days after this vulnerability was published, we keep on updating that. And with every new vulnerability that there is, we publish a new one with all the details. So this would be a great way to be updated on the latest news. Cody, I can't hear you. I'm not sure if it's me.
Hi. Sorry. Thank you, Beth. Thank you for
Right.
that. I'm going to wait for just a few more questions to come in, but in the meantime, I'll go ahead and announce our Amazon gift card winners. So our first winner today is Dirk B. Our second winner today is Don A. Our third winner is Hugo O. And our fourth and final winner is Lisa M. So congratulations to the four of you. Keep an eye on your inbox to claim this gift card. And if you don't find an email, just check your spam folder. Cherie and Daniel, thank you so much for being here with us today. I wanted to give you two the chance to close out with any final remarks you might have, anything you think our audience absolutely needs to know before we sign off today.
So thanks, Cody. The first thing I wanted to say is that, again, thanks everyone for joining. I did post in the public chat the link to the Log4j detect distribution on GitHub. This is, again, our open source tool to detect the Log4j vulnerability. So if you want, you can definitely take a look and try it out.
All right. Daniel, do you have any closing thoughts, or are we ready to close on out?
Thank you all for joining us today. I really appreciate that. I think this matter is very important and it should have this stage. I think that's all. Thank you, Cody.
Perfect. Well, thank you, Cherie and Daniel, for taking the time to be with us, for putting together that demo, and for really having the expertise on this very, very timely topic. I know everyone's talking about it, and we need to get this information out as fast as we can. A quick reminder that today's session was recorded. So following this webinar, you'll receive an email to access the on-demand. And you'll also find the recording living on the DevOps website. You can just visit devops.com/webinars and look in the on-demand section. Thank you to WhiteSource for sponsoring today's presentation. Thank you, Cherie and Daniel, for being here. And again, thank you to our audience for being here with us for the entirety of today's presentation. This is Cody J. Brown signing off. Have a great day, everyone.